So so let us start. Okay, so advanced algorithm, right? So today he discussed which lecture you said? Lecture 2?
No, not lecture 2. This is
Actually from this one, right?
This is I think it's extraction from this.
This one, right?
Yeah, no, this one.
no, the
This
second
one.
one.
Oh,
Yeah.
second one.
Just view first before you download it.
Okay.
This one.
This one he started this one, right? No, he started from here. Oh no,
Yeah, you start from here.
this one, right?
And this too.
Okay. Steiner graph. Okay. What is it? Okay. So let us discuss this. So Steiner, he says Steiner tree problem, right? Given a set A of points in a plane, okay. So these are the points, right?
Yeah, these are the points. We call them terminals, right?
Okay. He called them these are terminal, right?
Yeah.
Okay.
Cost.
And
Excuse me, can we zone it?
yes, slide.
Then zone it. Make it bigger.
Okay. So next time I can make bigger. So you gonna draw?
No, I don't draw. I just want to
Okay.
see
So
the...
Euclidean matrix for this one, right? So this side is 1, this side 1, this side 1. So these are terminals, right? You
Yeah.
said. And cost for this one is cost 2.
Yeah.
1 and 1. For this one cost will be 3, right?
The total cost is no.
No, this cost is 2. It because of the minimum spanning tree.
Minimum spanning tree, right?
Yeah.
So this one is minimum spanning tree, right?
Yeah, and he discussed to have a better case for minimum spanning tree. That's why we provide this problem.
Okay. So
Yeah.
so this one is minimum span cost is in general 2, right?
Yeah.
2.
So to the shortest distance
Yeah.
to reach to a edge
Yeah.
is 2 in case of Euclidean distance,
Yes.
right? But we can add Steiner points,
Okay.
and in this way we can reduce this shortest
So if
distance.
we add a Steiner point over here,
Yeah, we
so
put-
what will be this distance?
The
I think
distance
it's-
is 1 divide 3.
So this distance will
1
be.
divide
So let us
3.
consider that this point is G, right? So if this point is G, so then what will be this distance? This distance.
Let me draw them
Yeah.
on the paper. This one, if this one 1, 1, 1,
Yeah.
so this means this part is 60 degrees,
60.
right?
Yes.
So this part is 60.
Yes.
So when you draw a line, this is
Okay.
a triangle,
Okay.
and you draw a line here,
Okay.
triangle, draw a line here.
Okay.
There's a point here.
Yes.
So this part
Yeah.
is 2, 1.
1. Okay.
Okay.
Yeah.
So
2.
if you see only this part is 60 degrees, 1, and this point is 2, or
So like this, kind of tree.
so it's this long,
Draw, right?
and you need to divide 2. So finally it becomes this one.
1 divided by under root 3.
So this is how you get this distance.
So for this one, this side will be 1 and this side will be 2, right? Okay. This side will be 1 and this side will be 2, right? So this angle
Means
is
it's
60.
1 This coming 1.
Yeah, 1:2, right? For all the 1:2. So then how can I find? So this side will be √3. Oh, total. This one is half, right?
Yes.
This side is half.
Yeah,
this
there's
side
one.
is 1, right?
So this total length is
the distance is A and this is B.
so the total length is this one.
B and C. Then AD will be square root of 1 squared minus half square, right? 1/2 squared, right?
AD?
Yeah, AD will be, right?
AD?
Yeah, will be square root of 1 squared minus half squared, right? This is the point in between B and C, right?
Yeah.
So this side will be 1 squared minus half squared, right? What is that one?
Yeah. What is this distance you calculated?
How did you get 2?
How did you get 2?
If the triangle is 60 degree, 30 degree, it's always be 1, this one and this one.
But this one is half. Okay, so if this is half, then
So
this will be half.
so finally when you depend what's the length for this one, you just need to, for example, this is 1, so just 2 divide 1.
Can you find 1 squared minus half points? So this will be like square root of
It's just like
1 minus 0.25, right?
so if the square is like this one, it's always 1 1.
0.75. Is this one?
0.75 square root. 1 second.
Yeah.
Where is point?
Yeah. So finally is this one. The same like what I
It's
showed you.
0.866.
0.866.
66.
So this total is 0.866, right? This total AD, right? And then this part will be, so that we need to find out actually this, right?
0.866 plus 0.866.
No. So this is 0.866. Then 1/3 of 0.866 is this one.
Don't always change to 1.66. Use partition number like this one. Otherwise, it will be no trouble.
Yeah, I know. I put the dates down.
So the total length will be this one. A to D. Total length will become this one.
Okay, we can calculate its value, right?
Yeah, the value
Yes.
this one.
Yes.
This one is correct.
Yes.
What's the
1.7.
value?
Value is
0.866.
this one.
So
Yeah, √3/2. Yes.
root 3 by 2, right?
1.712 divided by 2.
3 divided by
It's just a number.
0.866,
So,
yeah.
so when the triangle is 30 degree, 60 degree, 90 degrees, always be 1 square 3 2.
Okay,
Okay.
that will be the ratio. Okay.
Okay, so this one you said for 60 degree. So for 60 degree triangle, you said this side will be
60
yeah
degree,
√3.
30 degree.
If this is √3 and this is 1, then
And
this is 2.
the stereo point is always 1 in this part. 1. What does it mean? How can I call this one? This symbol.
But we need distance from this point, right? We need
What?
distance from distance from
Email you the name of that student. Sorry.
What,
I wrote it
what do
down.
you mean?
so we need distance from this distance plus this distance plus this distance, right? So then what will be this distance?
The same, because
This
there's
is
1 1 1.
0.866, right? All the red edges will have distance of this 0.866. So in order to reach from this point to this point, it will become, I think, 0.866 plus 0.866.
No. 0.866 is this distance A to D. This is from A to D is 0.866. We got A to D. This distance. A to D is A to D. Right? So we need to find this distance.
That's same.
This distance, right?
That's same. Because it's 111, so the distance will be same.
Okay, so let us understand. We will see that. So this cost will be root 3, right? For rectilinear. So 1, 2, 3, 4, 5, 6, right? For rectilinear. 1, 2, 3,
4. That's 4. That's correct.
4, and 5, and 6. But if we make this point,
Yeah, so the cost is correct, right? So you
1, right? 1.
yeah, this one is correct, 4.
Yeah, 4.
And this one the square string is correct.
Okay.
Okay, so next slide.
Okay, Steiner tree problem. So in graph, given a graph G of V, these are the vertices, edges and cost, and terminal S is in V. Find minimum cost tree, right? We need to find some minimum cost tree. Cost tree spanning all terminals. Okay, MST. So does not use. So MST algorithm does not use Steiner points, right?
Yeah.
General algorithm, right? So it says find G of Steiner points, right?
No, terminals is
Yes, for
because there
terminal,
are
right?
no standard points in MST.
Okay. So here they said
Graph of terminals.
let's do this thing. Okay, find. Okay, find graph of terminals, complete graph on terminals, and then S cost is equal to shortest path cost. Find Steiner. This is Steiner, right?
Yeah.
Steiner terminal. Equal
No. What is T?
Steiner. Steiner. T for Steiner.
I think the T means terminal.
T is for terminal.
No, terminal is S.
Terminals are
And
S.
terminal is in
T, find T is MST.
What is T here? Here in our
Is it time complexity? Replacing edge of T is
I don't think he mentioned it. We can check the textbook.
tour. It is tour.
Tour, okay, it's tour.
Tour. Okay. Tour of S. This is tour. Equal to MST. Okay. Find the tour. Okay. With the terminal, there will be MST. It's minimum.
spanning tree.
Spanning tree. Okay. this graph, right? Okay, replace each edge of tour is with the path in S. So what do you?
I think TS means minimum cost spanning tree. It's not tour. I think TS means minimum cost spanning tree.
So let us see here. So this example.
Yeah.
Okay.
MST less than equal to short
So minimum main spanning tree. Tree.
to approximation.
Heuristic. Okay, MST heuristics is a true approximation in graph. So we need to prove MST is less than shortcut tour. Okay. Is less than tour. Okay. Equal to 2 times optimum.
Optimum tour.
Okay. So that means tour is gray, right? This gray line.
Yeah,
This
exactly.
gray line tour,
Yeah.
right? Okay. And let us see the optimum is a red color.
Yeah, optimum is the
So
red
for
one.
these one and this one, this is the optimum point, right?
Mhm.
Here, and this one here, this one, this one, this one, this one, and here, and this one, and this one, right?
What is this? Okay, this is MST, right? Okay, this
So-
is MST.
So yeah, this one.
is tour.
This one is MST.
Yeah.
The black is what? You said black.
Black is MST. Minimum spanning tree.
Just check the video.
Gray MST. Tour is black color.
Just check the very video if you draw it from the beginning.
Okay. Yeah, I saw the. Let us understand here. So, which color is tour? So this fade color, right?
Yeah.
This black color, right? This is the black color, right?
No, the fade one. The fade,
MST.
which is I think gray color, right? This. This is tour. What
Which
is
one?
MST? MST. This is MST. The black one.
The solid one.
Yeah, this one.
So from here,
MST.
here
Yeah.
to here,
Mm-hmm.
and to here,
Yeah.
and to here, and then it is back, and then this one, and then what?
Shortcut tour.
So this one.
Yeah.
How can I do the MST here? So for this one to this one and then back.
You're talking about tour, right?
Yeah, true.
Yeah. So the tour would be like this one. If you can start here.
Okay.
You go there,
Yeah.
there.
Yeah.
You
Yeah.
go there, then
Yeah.
come back,
Yeah.
then maybe
back.
go there,
Yeah.
come back,
Yeah. Come back.
this way, this way, this way.
And then
it's-
go here,
it's
right?
Complete circle, yeah.
And then again come back here.
Yeah.
Where is stop?
Hmm?
For the tour, where is stopping point?
So yeah, your starting point is your stopping point. You have to come back because it's a tour, right?
Okay,
You
so
have to
let-
make a complete circle.
so
So if you are starting from here, you have to
the
end
tour
here.
is this one. Maybe this one to this one. Here this one.
Yeah.
To here this one.
No, no,
then-
that's this one because this is the minimum spanning tree, right?
I think this one is minimum spanning tree.
Yeah.
This one, I'm asking two, like this fade on, right? From here to here to here, to here,
Yeah, yeah,
to
correct.
here, to here, to here, to here, and to here, right?
Yeah.
So this is
That's
the
two.
2, right? Okay. And then this is 2. And then MST here, to here, to here, to here.
What is this shortcut tour?
Where is the shortcut to?
This is the green one, right?
Yeah. So what is the green one? Do you have color picture for the green one? Shortcut.
If you want to show these
Shortcut
tools,
to.
Can you show that video? What is the shortcut tour? Can you check it?
So this is solid, right? 2 is solid, right?
oh, the green one is
This one, this one.
2 MST.
Oh,
And
okay.
the tool is black.
Shortcut tour is 2 MST. Yeah. So the shortcut tour is around these 10 points.
Shortcut
So
is this
yeah,
one.
so you can start from here.
Yeah.
From here you go there.
Here, go here.
Yeah, then come back. You have to make a complete tour
So,
here.
so let us go from starting from here, right?
Yeah.
Then
Yeah.
here,
Here.
then
Go there.
go there,
Go up.
go up, go
Come
down,
down.
down,
Up.
up,
Go there.
there,
Okay.
in here,
Mm-hmm.
in here,
Yeah.
here,
Yeah. Come
Yeah.
back. Yeah. Up.
here,
Come back.
come back,
Yeah.
here,
Yeah.
here,
Mm-hmm.
here,
Mm-hmm.
here.
Yeah.
I have still this point. I
Yeah.
think that this one here
Make a tour.
and
Go and back,
here.
and then the starting point. Yeah.
Okay.
So that's the shortcut tour.
So it will be greater than MST.
Yeah.
Shortcut to greater than MST, right?
It will be greater than MST.
Okay. Now let us understand MST. MST from starting from here
Mm-hmm.
to here,
Yeah.
to here, to here, and go here
Yeah.
and back here.
This is just MST. There is no tour here. Tour is different. Tour you have to come back to the starting point. But this is just MST. Okay. This is
Okay.
MST.
Okay. Then let me starting. So starting from here,
Yeah.
we need to go here, right? We need to go here,
Yeah.
and then here.
Yeah.
Then from here,
Yeah. Go up.
go up,
Yeah, and go back.
go down,
Yeah.
and then come here
Yeah.
and go up,
Okay. Yeah.
come back.
Yeah, but you don't have to come back. Minimum spanning tree is basically the shortest distance between two edges, right?
Okay.
If you want to go from here to here, then you will take this route, okay? If you want to go from here to here, you will take this route. It's just a distance between 2 points.
So why did he draw 3 different circular path?
Yeah, there was full components. Full components is basically, he said, this is one component. These two are the component. Second
This is the other component,
yeah,
and
this is the third component.
right? So what is mean by full component? Do you understand full component? So for MST, it will cover all vertices.
Mm-hmm.
So then starting from here,
Yeah.
I will go here, right?
Mm-hmm.
Then I'll go here.
Mm-hmm.
Then I will go here. Then I don't need to go back here. I don't need to go here, but do not need to back.
No. Yeah. You just go there.
Go there. Then this is one side.
Yeah.
Okay. And then if I start from here,
Yeah.
I can go here,
Yeah.
and then I can go up.
Mm-hmm.
Then I don't need to come back here. How can I go here?
Go where?
From here, I'm here at least.
Is there a okay? Yeah.
So I'm here. So how can I go?
You want to go from here to here? Yeah, you
No,
can use
I-
this route, right?
No, for instance, I'm starting from here. Okay.
Yeah, from here you want to go there because it's always between 2 points.
MST.
Yeah.
So is MST uses maximum?
In MST, you kind of calculated the shortest distance between every two edges.
Okay.
So if you want to go from here to here, you
Yeah.
have this option, you
Okay.
have this option, but the shortest part is this one.
Okay.
So this is MST.
Okay.
You're kind of calculating minimum distance between from one edge to every other edge
Yeah.
in the tree.
Okay. So in this case, I will say so minimum. What is MST?
So why this one will be grouped together and these two and these three?
Yeah, that's my question. So why did you do this?
Yeah, it's full component, right?
What is full component?
I think what full component is. So this is a spine, right? That's spine. Okay. The red portion.
Okay.
Okay. This is called spine. Huh?
Okay.
So the edges which are connecting to the spine makes a component. Okay. So for example, we have this spine, these 2 points, and edges are directly connecting to them. Okay. So that's why it's a full component.
It's a full component.
Yeah.
Right? Okay.
Then here comes this edge, right? It is connecting 2 edges, 2 points here. Then it's our second component. Then this point, it connects 3 edges directly, right? So this is our third component.
Okay. So why he did not make another central point here that would connect these, and these 4 points?
What central?
There could have a common point between these 4 points, right?
But there is no point, right? We are just considering if we have this Steiner path, then we have to identify the full components. So this is given. This path is given, right?
Okay, yeah.
This red path is given. You have to identify full components.
So he said there are 3 full components.
And
One,
definitions here.
full component is Steiner.
Over terminal subset in which all of the terminals.
Let's see. Full component in Steiner path.
Yeah. All leaves are terminals and all inner vertices
Okay,
are Steiner
full-
vertices.
Okay, full component in a maximum subtree which all leaves are terminals and all inner vertices are Steiner vertices. You mean that?
So the inner points are Steiner vertices and the terminals are edges basically.
What does this mean?
Here you can see.
So let me get this definition here. Because a full component is the maximum subtree, right? Okay. In which all leaves are terminals. So what are leaves? These
Leaves are the black ones here.
leaves, right? These big are leaves,
The black
right?
dots points are
And all inner vertices,
are Steiner vertices.
these are Steiner vertices,
Yeah.
right? Red are Steiner vertices, right? Okay. So
that's why it's a full component.
So, if I take the entire graph, that will not be a Steiner component.
That's
No,
the
No,
other
because
example.
then it will be in the center, right?
That's the other example. So it matched to this one. Remember this one?
Yeah.
Yeah, same as this one.
Okay.
So there should be a Steiner point in between, right? That's the condition.
Okay. So since
So
there is
in
no
this fully
Steiner point
component,
here,
we
right?
have Steiner points here. Steiner point here, right?
Okay, but for
Yes.
this one, there is no Steiner point, right?
But
So
there
you
is
don't-
there
you
is
don't
this
have-
connection.
So connection will be one.
Yeah.
Okay, the
Connection
connection is
should-
one, second one, and then this one is another one, right?
Yeah.
Okay. Then the approximate ratio.
It's set up.
So, right? So For Euclidean Steiner tree problem, approximation ratio is 2 by root 3. Okay, so this is why he put 2 by root 3, right?
Yeah, there's the same thing.
Okay.
So this distance is 2. This distance is 3, right? 2, 3.
So this distance is 2.
There's
Yeah.
1.
This is 2.
2
I
minus
think.
1,
You were
so
saying
there's 1.
Why 2 minus 1? So these are the parties number 1, 2, 3, 4, 5, 6. Okay.
I think this one should be a 2 minimum spanning tree cost. So that's why you times 2. So if that's 1 minute MST cost, should be 1 all to k, right? So k minus 1. But if there's 2,
But there's not a tour, right? You're doing a tour.
no. 2. This one is 2 minimum spanning tree cost. Because that's why he ties 2.
I mean, let me explain to you. For example, we have what we are doing here, right? If you want to go from here to here, it's 1, 2, 3, 4, 5, right?
Yes.
It's k.
K minus
K minus
1.
1. K minus 1. Why are you multiplying it with 2? Because the
Because
distance between these edges is 2.
No,
Every
we're
edge
coming
is
back.
two.
No.
we're coming back.
Because there's
We're coming back.
No, I don't think we are
because
coming
this one
back,
is 2
because this-
minimum spanning tree cost.
When you come back, it's a tour, right? But this is not a tour. This is a simple MST.
Okay, so then how it is 2? He said like this: 2 into k minus
Yeah, 2k minus 1.
1. Right?
Yeah,
Yeah.
So this is k equal to here, for instance, 6.
yeah.
So this 1, 2,
2,
3, 4, 5.
5, yeah. So it will
Right?
be 5.
And then he's coming back. Then this is why 2 times.
The distance is 2. I'm saying the distance is 2. That's why we are multiplying k minus 1 with 2.
Is the distance 2 or
It doesn't mention the distance is 2.
No, he mentioned it. I remember.
mention distance
yeah,
2?
he said
and then this side
This
is 1.
black distance is 2.
Okay, then-
I'm not sure about the red one, but this distance is
So
5.
then let's go. So if the distance is 2,
Yeah.
then this side is root 3, right?
Yeah.
No. Then this side is 1. If this side is 1, right? So this side, if it is 2, you see? So
No, it's nothing to do with this one. No.
No.
Because you know this approach depends on the angle, right? We are not sure what the angle here is. If the angle is 30-60, then this ratio holds true.
Okay. So he said cost is k, right?
Yeah.
K means
Optimal
it
cost is K.
1. So this side is 1, this side 2, 3, 4, 5, 6.
So this distance is 1.
Is this is 1, right?
Yeah, because optimal cost is k, right?
Yeah.
So this is 1, 2, 3, 4, 5, 6. It's
Okay.
k.
Okay. So then if this side is 1, right?
Yeah.
And then if this side is 2,
Yeah.
this side can be 2. You remember that he said this distance will be
yeah.
2? You remember?
I don't think you remember he mentioned
I don't
that.
remember that this distance is 2.
And it makes sense, right? Because
Okay, please draw.
yeah, let's do it like this, right? You know, we have 2k minus 2.
Okay.
So this is 2. This is 2. This is 2. So k is 3, right? And it will be 6. So that's the same, right? If we put this distance equal to 2,
Yes.
so it will be 2 plus 2 plus 2, 6. And what is the value of k in this case? K is 3, right?
K is 3, 4.
1, 2, 3.
4.
K
K
is,
is number of nodes.
yeah, but k minus 1 is 3, right?
Yes.
K minus 1 is 3. 3. You can multiply 3 by 2, it will be 6. So they are equal.
So then if it is k here 6, right?
Yeah.
Then k minus 1 is 5.
Yeah.
So then it is 2, 2, 2, 2, and 2. 5 times to 10, right?
Yeah.
Okay. So I'm not sure that how did you get Steiner point is 1 here? How did you get distance 1 here? Why this distance is 1?
No, I mean he supposed that the distance is 1. It could be anything. It doesn't matter. Because he mentioned in terms of k, right? So the distance value could be anything. It doesn't matter.
So here to here Steiner point k, and then optimum ratio he said 2k 2 into k minus 1 divided by k.
Approximation ratio.
So he mentioned this is 2, right? So that's it from here.
Approximation ratio. I don't understand this third part. 2 minus.
So he said this divided by this.
Uh huh.
So this divided by this. In case of k is larger than, then this that will be 0. 2 divided by k is 0. K is very large. So this 2 minus 0 is approximately 2.
Why is dividing it with k? Okay.
Ratio.
You have to divide from this to this.
This is
Yeah.
ratio. So
This by this.
So
Okay.
it's MST define optical.
Right.
Then let us go to the last point.
He did not
Cover this.
teach this one. Yeah, he did not cover it. And can you describe what he mentioned in the beginning of the class?
Nothing.
Nothing.
So he has discussed.
He just talk about the
Coronavirus.
Wuhan virus.
You guys have a class, right?
Yeah.
Yeah.
Class. So let us sit after every lecture.
Yeah. It's very beneficial, I guess.
Yeah, so we can discuss. And otherwise, it's difficult. So I have a YouTube channel. Okay, I will put this video on YouTube channel,
Okay.
and I will share with you. Okay.
Okay, thank you.
Can you please open YouTube?
Hmm?
Open in YouTube.
Huh?
Open YouTube.
Subscribe.
Yeah, subscribe my channel.
Subscribe and like.